And then I realized, I don't know if you guys watched Black Mirror. There's an episode where uh, a wife's spouse uh, died, uploaded all of all of his information, all email, all conversations, all images, all videos, to this and created a model. And it really, I don't, it's pretty it's not entirely dystopian. I could totally see like, us doing that now. I wonder if that is it. Like, I don't know, what is that? Like a model as a service for your deceased like significant other? Like, like that seems like
Okay, this escalated quickly.
exactly. It seems
But
kind of like crazy. I don't know if that exists yet, but like everything is here right now for that Black Mirror episode, at least a portion of it, to be here and present with us all. It goes like even deeper into creating like a clone of this person, which was, that was pretty weird. That was, pretty weird. But I just rewatched it. It was really good. Have any of you guys seen it or know what I'm referring to?
I haven't seen. I might have seen it, but I also had seen that OpenAI kicked somebody off of their service platform for doing exactly that.
Oh, wow. Wow.
Yeah,
I didn't
with
hear
that
that
deceased
one.
spouse.
I've seen that episode. It's pretty interesting one. One of my favorite ones actually,
Yeah,
because
definitely.
it goes pretty deep in terms of when we have these technologies, what are the social implications? I think I
Yeah.
think Black Mirror is really good at as well. It's like sort of tying in technology and societal implications. Um, but yeah, it's
Maybe
interesting.
we can have a movie night where we watch that Black Mirror episode together and discuss the implications. I think that'll be good.
Exactly. It'll be AI safety research. Nice.
Black Mirror was all about AI safety, really. It really kicked it all off.
Exactly. All right, cool. Well, let's get started. Uh, so first on the list is Felipe with Contract Sentinel. I've already taken a look at this of what he's building. It's super cool. I'm interested in all of you being able to see what he's got so far. Please take it away.
Hey guys, can you hear me?
Yes.
Yeah. Okay. So I'm going to talk about an important issue on the field of smart contract development. Smart contracts are prone to errors and vulnerabilities. This can include like incorrect code logic, improper use of library, or insufficient testing. So this issue can lead to serious problems like loss of funds. As an example, the DAO lost $50 million in 2016. Um, so my propose is an app to analyze this smart contract code and identify potential issues and vulnerabilities. The app will be trained to recognize this type of vulnerabilities. Commonly found in smart contracts. So you can use the app to analyze new or existing smart contracts and provide some uh, solution to these vulnerabilities, recommendation to address or mitigate these issues. I'm a front end developer, and I have been an entrepreneur for like 6 years now, and I have been building companies to help others to be better. Right now, I'm using one OpenAI model to test this application with real users and get some feedback. So this way I can like understand what they need and come with a custom solution. Because I noticed that some of you were concerned in the last round, like how it will be built, the model to find these vulnerabilities. Uh, but my concern first is like know what I'm building, what are the needs before I start building like the app actually. I believe this app will make a real difference in the field of smart contract development, and I hope you see this too. I don't know how to share the screen, so maybe
Yeah,
I can share.
down at the bottom, there should be a right next to your camera icon, there should be a screen icon. You can click on that and it should be able to allow you to share if you need to do so.
So tell me if it's working right now.
Oh yeah, perfect.
Yeah. Okay. So you can come here. Uh, let's copy this smart contract. Uh, Sorry. And it will generate a report of vulnerabilities if I here check for the vulnerabilities and give you an explanation. And you can ask to give some code suggestions to fix those vulnerabilities. So that's basically what it does. Actually, is using just calling like with a prompt the OpenAI model. Yeah, it got like some good results. What it lacks is like consistency. Sometimes it gets the right answer, but some like 90% of the time, but other times it get it totally wrong. So if you have some questions.
Super cool. Did you say you're using OpenAI? You're using GPT-3 rather than ChatGPT?
Yeah, GPT-3, like Da Vinci, I think it's called. Yeah,
Cool. And you're just making calls to the API. You're not
yeah.
using like a prompt engineering library or anything like that.
No, I
Okay.
made the prompts. Yeah.
Cool.
What are you doing next? Like I, I have context. So like last round, this wasn't built at all. Now this round, we have, everything that you just showed us. What is next? What are you
Mhm.
going to be building on top of this?
Well, right now I'm getting like feedback from some users, like the UX experience is a little rusty, so like fix that things. But I'm not sure what they telling me if, for example, a web app is the way to go. If maybe a VS Code extension is a better option. So I'm looking into that.
Nice.
This can tie in with a bunch of stuff. It'd be really cool. For example, the reason I asked like prompt engineering workflows is that you could, use calls to OpenAI along with other steps, which could be things like, I don't know, maybe you could like simulate something, some actions in the blockchain. Maybe you could use Brownie or something. So like if we can tie in language models along with maybe like simulation tools or something in these like complex workflows, I think that could be a really powerful combination.
That will be awesome.
I think one thing I mentioned previously in round 8 in the forum post is how like the heuristic method is just a pattern matching method, and without having the state data in addition to the code, it's hard to say whether or not you're going to have bugs, because a lot of the bugs are not just simply the code, but how the state of the system is in addition to the code. Like the state of your state of the database. Can you hear me okay?
No, I hear you very, very low.
Okay. What I mentioned before is that there's a heuristic model that these language models are using.
Yeah.
And I don't know if this is the best way to find bugs, but one of the things that needs to be done is that you need to have something to retrieve the state of the blockchain, because it's not just the code by itself, but it's also
Okay.
the blockchain data in addition to the code, or at least in a traditional program, it's like your state data in addition to the code that causes bugs.
Yeah. I get what you're saying. Yeah, definitely this have a lot of room from improvement. I'm just like building a POC to check with users, and from there you can go as far as you want. But yeah, you're right.
Yeah, like far out, like really far out. You could have a workflow that pulls in data from the blockchain, then it like makes calls to both GPT-3 and ChatGPT, because maybe they'll find something different, right? And then there's going to be a bunch of hallucination there. So maybe some of the stuff is wrong. So then maybe you have some checks, whether it's like a simulation tool or something else. And so, yeah, I think, yeah, it could be really powerful. But yeah, for sure, just focus on the POC instead of this far out stuff.
Yeah.
Sweet. Next, we have Techno Shaman. Proposed
guys.
a framework. Yes, absolutely. Proposed a framework for hybrid intelligence. Are you there? You ready?
Yeah, do you hear me?
Yes.
Okay. So I just want to tell that I really love what you guys are doing, because you are in the front line of not only technical, but I would say socio-technical innovation, because every project will have an impact on our individual and collective capabilities. And why I am interested in that, why I am attracted to it, because, well, you know, I am a not recovering addict to enhancing my capabilities with technology. I had an Apple II computer 40 years ago, and then I became a proud and excited owner of one of the first Macintoshes. So I have never gone as far as to learn coding, so that's a big insufficiency that I have. But because I am a radical sociologist by training, I've been researching what's the potential of any technology for helping liberate us from any cognitive or socio-economic structure that enslaves us. So that's my prehistory, leading up to experimenting with generative AI, and to the research that I started working on, the title Developing Hybrid Intelligence in a Network of Human and AI Agents. I would probably need to briefly explain what I mean by hybrid intelligence is not just adding AI to human thinking and writing and creating. So it's not an addition. It's more. I'm more focusing on the synergy, the emergent quality generated by combining the best of what humans are good at and the best of what AI is good at. So that includes looking into just what is that best. Like on the AI side, I would think of decentralized AI, participatory AI, and explainable AI, best from the perspective of what I consider the best possibilities from the perspective of our social evolution. And on the human side, it's our capacity for intuition, for activating collective intelligence and wisdom that cannot be mimicked by algorithms. So I'm thinking of this hybrid intelligence as the intelligence of a new life form, basically. Something like a post-human life form, not in the sense that we are all becoming cyborgs, but something qualitatively new is happening when millions of people are playing with AI tools and unleashing amazing new waves of creativity, individual and collective creativity. So how can we augment that capacity for taking us out from the risk of collapse, basically? Or if collapse is happening, then how can we prepare ourselves to come out on the other end? This is the essence, this is the motivation of my research. So obviously, this is a huge domain, and I cannot just jump into it. I need to ground it in well-articulated, solid, conceptual and methodological framework, a framework that will also include a roadmap of implementation of this hybrid network of AI and human agents, complete with some use cases. So this is what I want to work on in the next month, if my proposal will be accepted. And for the approach, I am also the founder of Future HA. That's the home of action research for regenerative futures. If you want to look up at the website, maybe it's better if you if you wait a week, because it's in the process of updating, getting updated. But the reason I mention this because at Future HA, I developed the methodology of generative action research. I did that a couple of years ago, before I grew interested in generative AI, but the two are clearly a good match for each other. And I think in my application, I put in a link to the generative action research methodology, to the page describing it. So the deliverables that I'm suggesting is the concept paper that will have the literature review, explanation of the key distinctions, research hypothesis, and first draft of an integrated set of research questions. What else? A list of experts that I want to survey, and also part of the paper will be the draft of the research funding strategy, and a list of initial use cases. So whilst I am waiting for what you guys will decide, I am already talking with people who are good at the technology side. So I started attracting two, three people who are interested in working with me on this. And I also started exploring the use cases, what potential, one of the use cases would be the kernel community, where the founder of kernel expressed interest to work with us and become a use case for this. So I guess it's good I just stop here and let you ask questions. By the way, I would really love to develop this conversation even beyond this short meeting, because the more questions you ask me, the better are my chances to explore, expand, think about things that I may have not thought before. So let's do it a collaborative undertaking.
Yeah, awesome. Any questions? Anyone?
Yeah, sure. Can you hear me okay?
Yes.
Look, I think it's an interesting project. There's definitely a need to ask some of these questions. I think if I understood correctly, you're framing the research in a question of saying you can take the best from AI and the best from humans and try and combine these qualities, let's say. And this reminds me a lot of Gary Kasparov's discussions about AI, right? The idea that through collaborating with the AI, you would get a far superior chess player. That's proven to be absolutely false. And humans do not help at all if you want to play chess, right? You're far better just to let the AI do that. We've seen that in the Go engines, for example. Humans can't understand what the AI is doing nowadays, but they beat anything which tries to change what they're doing. So humans have sort of been outsmarted in those ways. And when we look at, say, this idea you mentioned of human, let's say, wisdom, and I think AIs clearly can immediately outplay most people in terms of, if you ask an AI what's a reasonable thing to do, it's going to be, in general, already today, ChatGPT will make better suggestions than most humans, right? Like the wisdom of what a human might have, to me, is like you're regurgitating socially constructed stories, and AIs can do that far better than humans already. I would say the difference between AIs and humans, one is humans are adaptable, and modern AI systems, contemporary AI systems, are not adaptable. You have to have an engineering team to adapt them. So that's one advantage that humans have. And the other is humans have motivations, right? ChatGPT has no motivation, right? So, but then you're immediately into the domain of ethics in terms of what do you want this system to do. And so I would reframe the question as being a fundamentally ethical question and not a fundamentally individualistic question in terms of how can I make a better individual entity. It's a question of like, what should we be doing as a collective, right? And then what an AI can contribute is arguably far more important is how does it make that collective function better, not how does it make the individuals better. I'll stop there, but hopefully that's some food for thought.
Thanks, Mark.
Yeah, what should we be doing? That's such a key question that we can't really expect AI to answer, although GPT does give answers to these questions when the question is raised in a very narrow context. But when there's a larger context, answering the question requires not only data and knowledge, the data sets that ChatGPT was trained on, but the interaction with human communities, with the collective intelligence and collective wisdom. Don't ask me about what I mean by collective intelligence and collective wisdom, because if you get me started, then I would never stop. This has been the center of my work for 30 years. So I have a quite deep research. I wrote a lot about it. So this is what I plan to bring into the research, hopefully with the possibility of moving from theory into materialization in code and action.
So I mean, I would say that one of the fundamental problems that we have is the framing of the question, right? That there is one answer. I think this is a classic sort of modern Western search for some sort of universal truth, right? That there is the right way that we should be doing things. This is clearly failing us. Like modernity has failed us, right? We're at war in Europe. We're in the front of global catastrophic disaster, etc. So clearly that doesn't work. The question is, how can we make a society that allows for multiplicity, that allows for diverging goals, right? That allows for different cultures to get on and do things the way they want to do them, like a multipolar world, you could say, and get the West out of the way of that happening, right? Because as long as we have this unilateral universalist mentality, there's no space for other people to breathe. So then the question is, how can AI help that come about? Not how can AI give us the answer, but how can AI give us the infrastructure to allow those types of things to happen, right? And I think that's where AI can give us. I mean, you could easily ask AI, is it a good idea to go to war? And it will already come back and say, no, that's not a good idea, right? It's wise enough. But that's not the problem, right? The problem is you have these conflicts going on where people are motivated and eventually want to kill each other over things, right? And AI doesn't want to do that already. So the problem's not the lack of wisdom in AI. The problem is the desire of the sort of modern mentality, and it's not just in the West, that mentality, right? It's infected lots of other cultures as well, to want this universalistic sort of, I want to win, or I want to find the one answer.
Is this call recorded?
Yes, it is.
Oh, good. Oh, good, because I would love to revisit what Mark has been talking, because I didn't quite hear well the voice, but if I can read, I will get it transcribed, and I will get back to you, Mark, because I feel that there is something very essential in what you are saying.
Yeah, it is recorded, and I'll make sure you get that. And yeah, so that's covered for sure. Thank you, Mark. And let's get you two connected. I'll even create a chat. We'll just get you guys connected, and we can hash this out, or maybe we can even create another event where we talk about this specifically, go a little deeper, have more time to it. Yeah, so that's something that we might be able to do. Cool. Thanks, Mark. Thanks, Techno Shaman. Next, we have Burlat with OpenBugger, a tool for injecting bugs into Python scripts.
Hello. Okay. Let's see if I understand how to make this work. You do see me full screen?
Yep.
We can see it.
Okay, perfect. I want to see your reactions. I hope. I mean, you can laugh at me as much as you want. I am seeing my own screen as well. So, thanks for organizing this, and thanks for introducing me to this reality. I didn't know about this sort of community, so it's very exciting to see people organizing outside academia or industry. So thanks first. So I will introduce the project. So I've started working over the Christmas break at this project called OpenBugger. It started as a discussion inside the Open Assistant Discord, which, for who doesn't know, is an open source project to replicate and improve over ChatGPT and make the model accessible with a completely free and open source license to everybody. So at the first crash of GPT, I, of course, moved into trying to see what other resources were there and jumped into OpenBugger, into Open Assistant. So the idea is that everybody has been pretty excited about how good ChatGPT is for debugging code, and we have seen an earlier example of how to use it specifically for contracts and Web3 type of code. And I'm much more interested in Python code because it's the code that we use to do neural network, which is what I kind of do for a living. I'm a machine learning scientist in a startup here in Italy after having worked in the States for a while. And basically, the idea of OpenBugger is to develop an open source package that is able to take Python libraries or that are already installed, or GitHub, or just large data sets of code, and introduce bugs into the code to generate basically a training set for machine learning models that can learn to detect code or learn to debug code or these sort of things. At the moment, it has been like there is a small working MVP that is basically like a small hackathon I made by myself. It's mostly using a regular expression to parse Python code together with the inspect module and search for possible target of the attack and introduce a modification and then outputs the modified code. Of course, this works at the moment for two types of code, of bugs, for two classes of bugs. And there are around 40 bugs. Those are syntax and logical errors bugs. I don't know if you have enough resolution to see the screen, but basically those are some of the possible bugs that are implemented. Of course, this is still an MVP using a simple tool like regex, and also it's not that scalable because one needs to develop a new regular expression for every new type of bug that you want to define. And of course, regular expression have a lot of exception if somebody knows, has had experience. So the idea is to move from using regular expression to use AST, a Python profiler, to parse the code in trees and use the trees to detect and inject bugs in specific location. So how does it work? You start with a script. Here is this medium script, which does something. And you can either give this script to one of the two classes, syntax bug or logic bug. And the script is going to be randomly modified by selecting one of the possible bug attacks, as you can see. So these are the example of the bug that are introduced. So these are all modified version of the same screen on top. On the left, you have syntax bugs. On the right, you have logic bugs. So you can see in the syntax bug, it is removing some brackets, doing operation that would break the code, like not closing brackets. And while on the right side is introducing a non-existing variable in the initialization or calling inside the loop or other things like that. So why is this relevant? The idea is to use this tool to enrich the reinforcement learning from human feedback pipeline that OpenAI developed to train ChatGPT. So this pipeline is mostly done by 3 steps. In the first step, basically, a pre-existing large language model like GPT-3 or like DaVinci now is fine-tuned on a data set that is specifically made of question and answer. So prompt. So this fine-tuning lead the model from simply predicting the next token to actually trying to formulate coherent answers, and especially gives memory to the model of the answers in the training set. Then the output of this soft trained model are validated by humans, and humans re-rank these outputs. finally, the ranking of the humans is used to develop a neural network that predicts the reward function, and this reward function is used to further train the model. And that's what gets ChatGPT. So how is Open Assistant going to, OpenBugger going to help Open Assistant replicate this pipeline? And we are going to contribute to step 1 and 2 for the part of training of Open Assistant related to code generation. So the first part, in step 1, the idea is that we can use the package to perform large-scale data augmentation on huge code dataset, so that instead of only having properly running code, that is what is currently in the curated dataset that are available, we can have properly running code, bugged code, and what type of bug has been used to bug the code. Then we can use these tuples of bugged code and bug types to generate imaginary question and answer conversation where a user has this bugged code and ask help to the assistant to generate to fix the bug types. Of course, the assistant already knows the answer, so we don't need to use a language model to create the assistant responses, because the bugged code has been generated by some correct code. And this allows to completely skip or enrich part 1 of the RLHF pipeline. And here we can, instead of using human feedback, we can use artificial intelligence generated feedbacks. The second part is on step 2, where instead we can train classifiers on these new data sets that we generated, made by correct code and bugged code, to predict whether the code is bugged and what type of bugs are there, how many are there, the severity of the bug, and other information that the profiler is going to give us. And then we use this model to automatically generate synthetic rewards for the code generated by a language model. And yeah, this is everything. In practice, this is what we're doing. There are already a few contributors that started helping. One of them is going to present, Fabrizio is going to present right after me, still working on, which is working together with the TRLX team on the RLF part. And this is pretty much everything. And if you have, I would love you guys to pass on the GitHub if you have any type of bug that you are typically encountering and you would love your next assistant to always be able to solve it. Please tell it, because the space of bugs is huge. So, and we are going to have to test that every bug works properly. So we want to start with the bugs that are actually useful for people. And yeah, and follow on Twitter that this account will become a product at a certain point, and then you can need followers.
If you want, link your Twitter in the chat. That'd be great.
Richard has it, and Algovera can retweet it from Algovera.
All right, cool.
Sure.
Okay. Any questions?
Yeah, any questions, anyone? Awesome.
So, are you familiar with mutation analysis?
Not really, but please enlighten me.
So,
are you speaking, is like mutation analysis in terms of code or in terms of evolutionary algorithms? Like, I'm familiar in terms of evolutionary algorithms, but I don't know much about automatic code parsing.
Yeah, so there's a long history in software development of an idea which is called mutation analysis. The basic idea is to make small modifications to software and then rerun the current test environment and see if the current test environment can find the problem or not. And this is a way of measuring the quality of your test environment. The background of that is that the ideas probably came from the microelectronics industry, where what they were doing in microelectronics was what's called fault injection. So you basically want to know, can your test patterns for a new integrated circuit find manufacturing defects in an integrated circuit? And to do that, what you do is you have to have good quality test patterns. And you need to measure the quality of your test patterns to know what the quality of your circuits will be when you based on defect rates that are found. And so they basically have fault simulators to do this, right? So you inject a fault into a simulated version of the chip and see if you can detect it with a test set. And so I think what happened is people in the software world saw that and applied it to software. And funnily enough, I come from the microelectronics background. and I sort of had similar ideas and built a tool, which the tool was called Certitude. And what that did is it applied mutation analysis to the software, to the software language which you use or hardware language we call them, that you use to program integrated circuits with. So there's these languages called, for example, VHDL, Verilog, which are sort of like C-level type languages which are used to define the functionality of integrated circuits. So Certitude was a tool which injected mutations into those descriptions. And then that was in a company called Certes that was bought like about 10 years ago. I think the tool still exists in a company called Synopsys. It's one of the largest software providers in the microelectronics industry. But so so I have quite a lot of history about that space because
it's amazing. Like I'm like, please come hang on the GitHub, tell us what we're doing wrong and what we can do.
I did share a link in the chat here to I just did a quick Google search, right, for what are the mutation analysis tools for Python. And so you can see there's a project called MutPy, M-U-T-P-Y, on GitHub that does mutation analysis on the abstract syntax tree.
Okay.
And so that's probably got a lot of the building blocks you need.
That's exactly probably what we were trying to replicate moving into AST. Where did you link it? Here in the chat?
Yeah.
Okay, perfect.
It says a GitHub link.
Okay, found it.
Sorry, maybe I should stop, but I feel like I should probably keep going because I probably have more experience in this space than most people should.
Yeah, no. Like tell us everything you know, please. This makes no sense, but probably more helpful than the funding. So
I'll try to stay short, but so basically, I don't quite understand the value of the syntax bugs, right? Because you can find those with other tools, right? Just a syntax checker will find those those are not. I'm not sure if those are valuable, but maybe you have some good reasons as to why you want to do syntax bugs. But I would, we didn't do anything like that in our tool, right? Because if there's a problem in syntax, the compiler will just fail straight away, so you can find the bug. There's no problem with those sorts of bugs in terms of finding them. The other point,
Mark, do you mind? I think there is so much that we want to ask you that it might be more meaningful to actually, if you can dedicate a half an hour, we can kind of have a meeting just on this subject and go deep.
Yeah, that should be fine. I think probably the more general, maybe I'll focus on a more general point, right? Which is, I think might link back to the DAO contract questions as well. Is what are these language models really doing? They are trained on a large data set, right? If you look at what how is it deciding on what's a reasonable answer to a question, right? It's a statistical, let's say, matching, right? Pattern matching to what's the most probable prediction this thing's going to make. Now that's to some extent the context that it gets is limited to what you can put into the prompt, right? So if you're a software engineer or if you're and you're developing these, whether it be a contract on a DAO or some software, the context that you have when you're trying to interpret a bug is usually the entire project, right? It's you have all the requirements in mind, you have documents in mind, you have all the rest of the code, and now you're looking at some little piece of code, right? And I think we've sort of been thinking about trying to do similar things, and part of the problem is you need to have some representation of the problem that you can get into the tool that actually captures these broader concerns, right? So and you're limited with what you can put in the prompt, right? So I think these are real challenges to think about, is how do you get all of the context that the actual human would have when they're trying to debug, make that available? Because if you don't put it into the prompt in some manner or fine tune the model in some manner with that, then all the model is going to do is give you some average case, best case guess across all of the code it's ever seen, right? And a lot of the time that'll be wrong because it's not going to be specific.
If you want, Mark, I can try to go a bit in details on what the models are doing, because that's mostly what I do. And and then maybe try to see why some of the intuition are correct, some are not. And that is the reason, like, that's how they used to work 5 years ago. And there are a bunch of hidden fixes inside that make it work much better. And like the final example is something we can start from. You're saying about that averaging component, right? What a really important component of the transformer are those attention heads that are really often spoken about.
Yeah.
And what the attention head is doing is basically deciding what is the support over the complete data set, over which to do these sort of averages, right?
You're right. You're correct.
So it's doing. So it's learning.
Remember, the attention head is trained on that global data, right? So what the attention head is doing is averaging. Now,
okay, my friends, I'm gonna have to come in. I'm gonna get you guys connected on Discord, and we will ensure this this conversation continues, because it looks like a lot of value is being exchanged. So yeah, awesome.
Thanks a lot, Mark, for.
Thank you.
I was all for going forward for the whole afternoon and probably night for you. So.
Yeah, I look forward to talking soon.
I dropped you a link to this Usenix article about debugging and correctness, and how correctness is not just like what your code is, but what your code is supposed to be doing, which requires like that outside context to your specifications.
Okay, just to summarize, given that at the end it's kind of a pitch for some money, the idea of the project is to generate data, right? To have a tool that can generate data that are controllable, basically by an ontology of bugs that can happen, such that the model, so that we can have attention heads, right, that are able to separate input code that it receives in the context. Like it can automatically isolate whether this code stays in the bugged subspace or in the normal subspace and so on, so that it has a simplified context. Like it's not solving anything that Mark asks for to have a complete context, but it's just a way to train the model to have a more organized memory for the sort of variation that code can have, some that make it not run and some that make it run. I concluded with this. Thanks a lot, guys.
Thank you for that. Thank you. Super excited you're here. Okay, so next we have Mistovan. Hopefully I'm saying that correctly. This project is around next generation for reinforcement learning library for transformers. So my friend, please take it away.
Hello, hi, Weiss. Yeah, it's the nickname, so I'm not concerned if it's mispronounced. Hi, so I want to present TRLX, and it's a Transformer Reinforcement Library X. This is a might license open source project, and it's being started by Carper AI. I'm Fabrizio Milo. I work a lot in open source. This is my reference. I have 45,000 on Stack Overflow, so I know something about programming. And a disclaimer, I don't work for Carper AI. I'm just a volunteer on the open project. And the open project of TRLX, what it is? It's a library to train reinforcement learning algorithms at scale. And it has a compatibility with the major open source library for this technology, where transformers are the class of neural networks that OpenAI is based on. Accelerate and DSpeed are libraries that are used to distribute at scale this kind of training process. In the context of OpenAI, that as we saw before, TRLX does this last part, right? Once you go through all the process and you have the data set, then you have to actually train and finalize the model. TRLX encapsulates all the logic that you need to be able to train that part. The current state is pre 1.0, but we have already some useful algorithms. One is the ILQL, and you can try to see if you can run it. It's very complicated, there is a Discord channel that you can join, and we can help you. And then we have also a proximity policy optimization, and this is the one used by by ChatGPT. Is being developed by OpenAI, and this is a reimplementation of that algorithm. So training TRLX, training reinforcement learning at scale, it can be very challenging, right? Like this is the kind of systems that you need once you have terabytes of data and you want to actually process all that data. And so there is a lot of machinery that you need to put inside the system. There are many dependencies, not as we saw before, that needs to be put in place to actually make all orchestrate and be able to produce the final asset that is the weights of the algorithm to be then used for inference. So to come to my proposal, like this is the current documentation, right? It's almost inexistent. It's just a few words here and there because most of the team was focused on actually creating the algorithms to create papers. There are a few papers coming up in these months about how they use TRLX to improve the state of the art. And so that's why I want to propose to leverage the resources to create a better documentation and provide a few examples like IPython notebook to be able to have more people have access to this technology. And so there is some work to do for making this happen. Right now are scripts that are being generated that have been written for the papers itself. They are not written for much less savvy or like experienced public. And so I think it's important to have those examples for new students and for anyone that wants to approach this revolutionary technology. I have for TRLX in the library itself, there is going to be a lot of things coming up in the next months. We are coming up with adding NeMo to the library. NeMo is the next generation of NVIDIA's transformers, so it's a very highly optimized library to run on this kind of clusters. Right, these GPUs, when we say GPUs here, it's most of the time NVIDIA's. And so NVIDIA has provided some libraries that are able to efficiently utilize their hardware. And so we are coming down, and that's a very big step because we will be able to train very powerful open transformers. And so this is the conclusion, like vote for me because I think this is an important addition to this technology. So I will take any question now.
Great, thank you. Yeah, any questions, anyone?
It's an awesome project, I think. It's really great to see that sort of idea of making the RLHF and then the RL AIF possible, right? And it wasn't clear to me if the current OpenAI RL algorithms are actually using transformers, because if I understood you correctly, part of what you're doing is actually applying transformers inside the RL algorithm. Is that right?
So the library is to orchestrate the model for reinforcement learning. The model itself is not so important, right? Like it's just one possible algorithm to run, the transformer ones. But to actually train the kind of chatbot that we're seeing in OpenAI, we use a transformer, and then that's the base algorithm. And then TRLX is able to orchestrate how this model, the transformer, learns through the feedback of the human.
Okay, so maybe I misunderstood, because it wasn't clear to me if you're just using like a more commonly known reinforcement learning algorithm. Like, so for example, like you need some model of some way of representing the policy, for example, and like I think that there is some work in some of the large companies where they're having success where they're actually using transformers inside the reinforcement learning algorithm, right? So like they're building a policy with, for example, transformers, and then you could apply that to something like a large language model, which also has transformers.
If you want, Mark, I can help you clarify on this point. So transformers are so huge in terms of memory that it's really difficult to just train them with plain gradient descent. And you need to do a lot of quantization and distribution, and you basically play with fire because you stay next to the numerical error bound. You want to stay as near to the numerical error bound as possible. And the numerical error for policy gradient with respect to gradient descent is a whole magnitude bigger. So that is the big technical challenge that at the end OpenAI was able to surpass, and a bunch of other groups, Google in first, by using transformers with RL, and especially very, very, very large transformers. Like I can train myself a small transformer on a grid environment and do RL on that, and that's no problem because the transformer memory footprint is neglectable. But but once you try to use something that requires 16 A100 and are sending ultra quantized, probably binary gradients around, you start having a lot of orchestration problem, and that's what TRLX tries to do, is to open source this complicated orchestration pipeline to system
so it really is for example, is the right way to think about it would be like you have something like the equivalent of, say, the policy network, and that itself, the policy network, is a transformer, and TRLX is what allows that to be.
And the policy network itself is the whole GPT. Like that is what ChatGPT does. Is like the whole policy net. Like it starts from a network that has some output probabilities that depend purely from self-supervised learning, next token prediction, right? And then it does beam search to produce multi-step outputs, and then they use RL to create a gradient for the whole multi-step output to basically realign greedy search to beam search. And they make humans go through the whole beam search and re-rank the output of the beam search and use policy gradient to back propagate basically from this maximization operation over the beam search back into the weights of the network. That is kind of what is happening from the technical perspective.
Okay, so
the model and the policy are the same.
So I had misunderstood this, or maybe I'm just, because my understanding was that what you wanted to do with the reinforcement learning of human feedback is you actually wanted to create a separate, let's call it, for give example, like a separate policy network that actually is just about learning human preferences. And then you take your pre-trained language model and your new policy network and use that in the third step, which is to take the human out of the loop, because you've used the human just to train up this policy network, and now you can
that
actually...
is called the critic. Like you can look a bit actor critic framework, and in that case, like what I'm calling the policy is the actor, and it's a bit of a misnaming. And what you're saying is the critic. Basically, it's two components. It's one component that is evaluating how good the value function is, and another component that is predicting the value function.
And you're saying that OpenAI is not doing that. They're not actually building a critic network.
No, yeah, they do. They just did not give anybody the code to do it. And TRLX is about sharing the code to other people to do this sort of thing. Like at the moment, like TRLX is replicating what they did in a way only with not inside the Azure cluster that probably has some custom orchestration code that is never going to be seen by a common
Quick
user.
question in the chat. Archie asks if TRLX is something like Hugging Face Accelerate.
No, we use Accelerate on top of it. Accelerate is a layer that just takes care of distributing. So you see this, I don't know if you can see the mouse. Yeah, right? Should be able to see.
Yeah, we do.
I lost the window. Okay, so let's see if I can explain. So this is the stack will be more or less you have accelerate, and accelerate takes a Python process, no, and it distributes on the GPUs. Okay, like it gives all the machinery to allow to have a process and the network run on the GPU, right? And what TRLX does is utilize that library to basically distribute the neural network. Let's say this is the neural network, okay? And if you load the neural network in a vanilla way, it will not fit on the GPU, right? Because there is too much memory. And so what needs to be done is you have to basically split it in different parts, and then you have to orchestrate how the gradients will all come together. No, you have to do a lot of machinery to actually make it work. But this is all that machinery is what TRLX encapsulates. So you just give this one, and this is like a Hugging Face transformer. Not like this is it's just a how you say a stock transformer. Like you can go to Hugging Face and and you just follow for a transformer. I don't know, like T5. Okay, ideally you will be able to just take one of these open source transformers and then add the TRLX on top of that in a way that you can then distribute and train your own neural network. Is that make sense? Did that answer the question?
Yeah, that makes a lot of sense. I think just to maybe I don't know if it'll help with your presentation, but if you just presented it as saying this is fine tuning of the language model, right? This is actually the algorithm to do the fine tuning. I got confused because you were presenting it in the framework of the RLHF, right? But this is really, there's nothing particular about this. Like the RLHF, you're just concerned about the fine tuning step, right? So it's sort of, and I think there seems to be some sort of need in the community, I guess, as well, that we need some sort of open source way of building the reward model, right? Which is the sort of, you know, you had those 3 columns in your slide 5 there. Like slide 5, the middle column of slide 5 is also missing, I guess, right? From an open source sort of flow. Like step 2 here, like you're talking, the fine tuning is like a generic problem just for fine tuning a large language model, right? But the RLHF is really the addition of step 2 is what's
yes,
unique about RLHF.
That is independent of, right? Like that is something. It does, like you don't need a big infrastructure to do that, right? Like a website and like a Python script will do that. Like you can run that process in a collab, doesn't need right. For OpenAI, I think it's 100,000, which is already a lot if done manually by a human, right? It's 100,000 created prompts, but 100,000 strings it runs on any computer. Like almost you don't need the barely thing. That's enough. So that's why it's like very different scope. And with TRLX you can train a full transformer. So that's like you can do only the fine tuning step, but you can train a full transformer end to end up to the PPO policy.
So we are about 9 minutes over. I am super happy that we have, this was like a really good batch of presentations and a lot of value was exchanged. Thank you, Esteban, for presenting. And I'll just have like, well, first I want to thank Silent and Esden for coming. I didn't get to thank you guys for coming earlier, but glad you guys are here. And yeah, some last minute community updates. So now open applications are closed, right? So I think we have, I don't know, like 16 or 17 applications for grants. Now, today starts the community review. Think of everything that we did, but we're going to be doing it async on the forum. So anybody who does a review will get a reviewer's reputation badge. A reputation badge allows you 1 vote towards governing which projects get funding this round. So today I'll make an announcement for everyone to know that we are in fact in the community review phase. I'll also announce additional ways for you to obtain more reputation badges, like we have the community member badge. I'll make sure you guys all have that. We also have a contributor badge as well. And yeah, I'll make an announcement today to list all the ways that you can obtain reputation badges, allow you to get more votes this round, and so you can help govern who gets funding. And that's pretty much it. We're also generating AI images under the theme of a historic computer science or AI figures. So if you want to generate like an AI image, you can do so. If you go, I'll just link that in the announcement as well. But would love for you guys to participate in that if you want. And those images will actually be our reputation badges. So any questions at all before we close out? Sweet, awesome. This was truly fun. I am literally going to take this, upload it to YouTube. I'll make sure you have it. And yeah, thanks for coming. Oh, we have one next week as well, January 18th. It'll be 5 p.m. UTC, trying to be fair for all the time zones that we have. And so hopefully you guys are there and we'll jam out again. That's all I got. Cool.
Thanks a lot, guys.
Everyone.
Yes.
Bye.
Thanks for that. Thanks,
Bye
Simon.
bye. Thank you.
Yes. Peace.